I don't want to leave out horizontal translations because think about it. We did vertical, it's time to do horizontals. And guess what? It's the same thing as we did before. Remember, we had a function of f of x like this, and if we had a horizontal, we said y equals to f of x minus this value here, whatever that value is, but it was a minus. So don't forget that minus switches things up because we know it's a movement right of C. Oh my goodness. So we are talking about left rights when what we refer to now in sinusoidal is phase shifts. Oh my goodness, a phase shift. Yeah, so basically take a look at your sine graph. We're going to move this over. Start it here and go over and do the same thing. Did we change the shape of the graph? No. Did we change the amplitude of the graph? No. The amplitude and the period are going to be the same. All we did was shift it. And what did we shift it by? That value from here to here is the value of C. You got it. So think about this. Look, this same idea now goes into sine, cosine, and tangent. We're just shifting it left or right. Okay, so in a horizontal phase shift, remember, if you're greater than 0, you're positive, you're going to the right. If you're less than 0, you're going to the left. Easy peasy. Now, the rule that we apply to the transformation of many different functions also apply to the transformation of sinusoidal, but be aware of that sign. Okay, so without further ado, let's go. Boom. Here's our graphs. Again, start with the reference. Always start with the reference, which is cosine. Okay? Then do your whatever transformations to it. Start with a reference, go from there. So remember, cosine is cosine cup. Yes, starts here, goes down through here, goes through here. And notice that the b value is still 1, which means that you have to go through a phase, right, of 2 pi, a period of 2 pi all the way through it. You're not phasing it left or right yet, just a normal graph. So remember what that means. And take a look. We're again going from minus 2 pi to 2 pi. So a positive and a negative cycle of the graph. Okay, so remember what cosine means. You start at 1, down here, of course, it's negative 1, and then you end up at 1 there. Halfway through, you're at your negative 1. So let's start. Let's just do it. Okay, there's your 1. Okay, there's your 2 pi, meaning you're back up to here. Okay, now remember, halfway through, which is pi, means that you've got to be at negative 1. So negative 1 is way down here. Okay, so here we go. Think about it. What is this point right here? That point is halfway between here and here. Okay, so halfway between 0 and pi, right, which is pi over 2, is where you're going to cut. And look at this. Halfway from here to here is when you're going to cut again. Okay, so between this pi and 2 pi, right, out here, 2 pi is where you're going to cut again. So that's going to be a cut right there. So look how accurate I can draw this now based on just my original template. There's my beautiful cosine graph. Now, do the exact same thing, but to the other side. Okay, no problem. There's my negative pi over 2. There's my pi, which is going to be all the way down here at negative. There's my 3 pi over 2, and then back up to the top. So I'm going to get a graph that looks an awful lot, again, like that. Beautiful. Okay, so there's my cosine graph. There's my original cosine graph. Now, think about what we're doing here next. The next thing is, oh, look at that. Watch out for that sign. Remember, originally, this is y equals to the cos of x minus c, right? But that's a positive, meaning that you are shifting negative 3 pi over 4. You're shifting left. Oh, we're doing everything by negative 3 pi over 4 right off the bat. Okay, so basically take everything and move it 3 pi over 4. It's as simple as that. Move everything over 3 pi over 4. Okay? All right, so how do you do that? Look at your graph here. Look how this pi is broken down. It's broken down into 1, 2, 3, 4s. Okay, so that means you're going to shift everything over 1, 2, 3. You're going to shift it over 3 units, but you're going to shift it left. So start here. Shift left. 1, 2, 3. There's your new dot. Okay? Take this point. Shift left. 1, 2, 3. Perfect. There's your next dot right here. Shift it left. 3. 1, 2. There's your next dot. Take this one. Shift it left. 3. 1, 2. Oh, we can't go 3 because it's only supposed to go up to 2 pi. So if we did, we know it would be here. And if we shifted this one over 3, 1, 2, 3, we'd be back up to here. So what we're going to do is we're going to do a little bit of kind of creative cheating. Okay? Kind of creative. Here we go. We're going to start from this point here. Okay? We're going to go down. We're going to cycle up. As soon as we start cycling up, we're headed towards this, but we're going to stop right at the 2 pi mark. Done. Okay? Draw the dots big enough. Yes, the line is there. Okay, so let's keep on going with the other one. So we've taken this one. We shifted left 3 pi over 4. Okay, and we know that each one is pi over 4, so that's where 3 pi over 4 comes from. That's where the 3 ticks come from. Okay, so we're going to take this guy now. Go 3. 1, 2, there's your new dot. 3, okay? Perfect. Let's go to this one. Go left. 1, 2, 3. There's your new dot. There, okay? Going to go to this one right here. Shift left. 1, 2, there's your next dot. And then finally here, we're going to shift left. 1, 2, 3, right here. And let's draw the rest of this graph. So we're going through this, through the big dots now, all the way down here, all the way back up to here. But look at this. We haven't finished yet because think about it. Think about it. We have to go up to 2 pi. Okay, so we have to do a little bit more of this. Well, that's no problem because think of your original graph. Your original graph went out here, right, up to 2 pi. You know that this is going to cycle down and start doing this again. Okay, so take this and go back 3. Let's see. Let's go back. 1, 2, 3. Oh, look at that. So we're going to start cycling down here, and we know that we're going to continue on until we get down to the 2 pi spot, which is starting to come around that way. See how it works? Really pretty, isn't it? Okay, really nice way of drawing this one. Now, let's draw in the last one, which is this one here. Aha! This one means, oh, look at that. It's negative. Watch out. So that means this is actually pi over 4. So you're shifting everything of the original graph, this guy. You're shifting to the right, pi over 4. Well, this becomes really quite messy. So let me get rid of the green graph here, and let's just leave the original red graph behind. Hold on. There's our original. Ha ha! A little podcast magic for you. Now, let's shift everything over pi over 4. So pi over 4 to the right now. Okay, so here we go. How do we know it's pi over 4? How many spaces do I move? Well, look, you're starting here. There's pi. Look how it's broken down into pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So each tick is pi over 4. So you're basically going to take this graph and you're just going to move it one spot over. Move it one spot over. Oh, can't see the bottom. So, oh, there's the bottom. Move it one spot over. There it is. Move it one spot over. Oh, this guy's up here. We're just going to move it one spot over. But remember, we only go up to 2 pi here. So let's show this part of the graph then. There we go. Coming around like that. Beautiful. And as we go up towards this, we're going to stop right at the 2 pi because that's what the domain restriction wanted us to do. Okay? Perfect. Now, let's keep on going with the other ones then. Okay, so pi over 2. So, or I should say pi over 4. One tick over. That's this new point. This guy is over here. This guy is now over here. This guy is back over here. But remember, that's our cycle here. And remember, this starts to go down over here. So let's just figure out the rest of this graph. It's going to go like that. Down over here. Up over here. And then it's going to be cycling back. And we're going to end it right there at our minus 2 pi because that's our domain restriction. So anything to sum up on this? Yeah, probably the most important thing to look for here, folks, is the fact of this sign change. Same thing that you did in polynomials way back when you did the translations moving left or right. Exactly the same thing. No difference.